All right, so the FlyingBergman boards are ready for the first delivery. I made six boards, which I ordered from PCBWay, and four of them are completely fine. I've tested all the hardware, and it was perfectly fine. Two of them are the ones that I fried, because the 5-volt regulator, I discovered after frying these two, that the 5-volt regulator does tend to get shorted because it's the smallest component on this board, and one of the things was that I didn't have small enough. Like I had to. It would have been better if I had more solder mask around the components and around the pads, and also perhaps made the pads of this 5-volt regulator slightly smaller. But during manufacture, it apparently tended to become shorted. But I repaired these boards, so they are all fine right now as well. At least for the motor control part. There is so there are a few chips around the boards, primarily the ones that are used for the encoder readings, which did tend to be kind of destroyed by the short on the 5-volt regulator, because then the main supply voltage was going to the 5-volt rail. But on these ones, at least one of them works, and I only need one for driving the servo motor, which has an encoder. The other motor has an analog encoder, so it connects to the analog inputs. But four of the boards, this is two of them. The other two are being installed in the FlyingBergman crane. The four of them are very nice, and I'm pretty happy with these boards. I think that they turned out, like they were not perfect, but I still think that they turned out pretty much as I would have expected. This hasn't been the case with some of my other boards, because some boards become like, if I don't review the boards properly, they do become kind of bad quality. Like I could have more faults than I would have expected. But with these boards, most of them worked very well once I kind of soldered them and got them actually working. And in case of the factory manufactured boards, I had to go over I had to like power them up slowly with a variable supply, just to make sure that all the power supplies are working. And after fixing any little issues that I've had on the factory manufactured boards, which were just a few issues. Like on one of the boards, I didn't have the current measurements from the DRV8302 chips, which drive the motors. And it turned out that there is one capacitor which goes to the GVDD input on the DRV8302 chip, which is on the back of the board, which in that particular case apparently fell off during manufacture, or maybe during transport. So once I placed the new capacitor there, I actually got the proper current readings from that DRV chip, which I thought was basically broken. At first I thought that I fried it, but it turned out that it actually works pretty well, as long as it has the capacitor on the GVDD. But beyond that, I think the factory boards work pretty much out of the box. With my own boards, as you have seen in a lot of my videos, this is the board that I've soldered myself. So this is the factory board delivered from the factory. It doesn't have all of the components on it because it's not necessary for this particular project. But this board is the one I soldered myself. And when it comes to soldering these boards manually, it is kind of a much longer process, because there's so many little places, primarily like the bypass capacitors. Where if you short one of them, you get a short that is difficult to find, because you have to check all of them. And the same thing with components like the DRV chips, which have a ground pad underneath. If you happen to put a little bit too much of solder paste on that ground pad, and then you press the chip down, the solder actually gets out of the ground pad and maybe shorts one of the pins, and you can't actually see that unless you remove the DRV chip from the board. So shorts like that are very difficult to find, and it's quite time consuming. I think the main thing about soldering the boards myself, it was the thing that took the most time is actually debugging the soldering work. Like debugging where is the actual short? Where is the 5-volt rail shorted? Where is the 3.3-volt rail shorted? Because I had different regulators, it was this task was slightly easier because I could kind of, if only one of the 3.3-volt rails was shorted, I could stop looking at the other components that are also 3.3-volt components, but which are connected to the other rail, and just focus on one rail. But it was still very time-consuming. And a few other little issues were the connectors, where I ordered the connector that was supposed to go cover the whole area here, and also was supposed to have 2 rows of pins. And I double-checked in my order. I ordered the right product code, which was in the catalog, but I got these parts which had to be fitted manually, even on the factory assembled boards. We're not going to be fitting the connectors on these boards though, because they are going to be soldered directly. There wasn't like in our motor part where we have the motors, we cannot fit the plug itself. But that's not a big problem. That's just an issue with the surrounding hardware. But when it comes to the boards, I'm extremely happy with these boards, and I think there is a lot of other things that are possible with these boards. I'm going to be exploring driving brushless motors, also driving coils, driving maybe a transformer, doing all kinds of experiments with these boards. I'm sure that there is going to be a lot of cool stuff coming out of them. And one thing that I haven't explored yet, because it wasn't a requirement for this particular project, is the EtherCAT interface. I haven't even tested whether this chip is working as it should, whether I can send packets, receive packets from the EtherCAT interface. So that's something also to check. I will get back to that when I have time. But on my end, I will just I'll continue working on the code for these boards, and then I will perhaps make the revision B of these boards for the FlyingBergman project or for some other project, because from my end, I design the electronics. I write the software and the electronics, and then I sell the boards to whoever needs them. So from my end, I just focus on the hardware and I just focus on the software. So that's it. And if you're looking for motor controllers, or if you're looking for boards that can drive inductive loads, you're welcome to contact me, and maybe I can find some solution that will work for you. Thanks for watching the video, and bye for now. So I'm going to stop this.